please fill in the blanks with me here. We're going to do the side splitter theorem. So if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. So what it's saying is when you have these sides here that are parallel, we know they're parallel because this little symbol, it breaks the sides. So like at R and X and S and Y, it breaks it proportionally. So in the past, so let's talk about what we did in the past. When you had a picture similar to this and you had numbers, so I'm just going to make up some numbers here. And I would often say the little triangle on the left has a value of 20. And then I would say on the left side, the big triangle has a value of 50. The little triangle on the right has a value of 15. And the value of the big triangle on the right side, you would just add up the two numbers to get 35. I just made those up. But the idea is you would have to compare the little triangle to the big triangle because it's really two pictures in one. Now, when the lines are parallel, now notice on the one that I drew up here, it doesn't state the lines are parallel. But now when the lines are parallel, it breaks it proportionally. So on the left side, we can say this top section is going to be proportional to the top section on the other side. Now the easiest way to do this is I just find the point like above or below the parallel lines, and I just do this little like bouncing motion. So if I start here on the left, I say segment QR over segment RX is proportional to QS over SY. And I have it written out right here. The idea is find the parallel lines, depending on how the picture is drawn or it's rotated, find the point that isn't part of those parallel lines. So for instance, if I continue this out and I continue this out, Q is the only point of the triangle that's left. So that's where I start. So then you just go down each side and write your proportion. And it saves you time. You just know the sides are proportional. Now we also have this corollary to the side splitter theorem. Now there are going to be three sides or three parallel lines that intersect two transversals. Then the segments intercepted on the transversals are proportional. So this one is it's easier than the previous. We're just going to match up the segments. And when we do examples, you'll see this one is quite easy. On the left top over left bottom, then right top over right bottom. So make sure you fill in this part over here where it says AB over BC equals WX over XY. Lastly, we have the triangle angle bisector theorem. So the name tells you a lot what we're doing. We have a triangle and we have an angle bisector. So if a ray bisects an angle of a triangle, then it divides the opposite side into two parts that are proportional to the other two sides of the triangle. Okay, so when you look at this picture, find where the angle bisector is coming out of. Now, I'm looking at these little markings down here. This tells me that angle A is where the bisector is coming out of. My bisector is really, it's ray AD here. So we're going to write a proportion. So starting here, just go around the left. So AC over CD, and then start back at A and go around the other way. AB and BD. So make sure you fill in this proportion over here to help you. Okay, again, we know the answers, they're written in, but let me explain them to you. It's really an easy process for this part. This is using the second thing here, the corollary to the side splitter theorem. If I give you AD and AC and AI, you're just going to tell me what piece is missing. And really, I mean, you can see here, we're missing this little piece, and I did it in green so you could tell. I'm missing segment IJ. So notice I put IJ in the little blank. So that's what we're doing for this section. If I get my eraser to work. Okay, next up, AB and BC and HI. Okay, that's pretty easy. I'm missing AH, so put AH. Now, if someone's asking, can you put HA? And you can, because you can name the segment from either end point. All right, moving on. BC, HI, IJ. So what are we missing? We're missing CD. So, guys, I know the answers are on here. Go ahead and pause the video. Don't look at the answers. Try to go ahead and fill in the next three and then see if you get them correct. Okay, so hopefully you paused the video. Now you're back. And did you get them correct? All right, so if you have questions, let me know and I will help you with them. But usually kids have okay time with those. Now for number 7 and 8, as you can see, these are a little bit more difficult. Go ahead and put the directions. The directions were on your paper, which is solve for x. Now, here's the clue. See this little parallel symbol? That means we're actually using the very first side splitter theorem right here. So we're going to use the side splitter theorem. You're going to find the parallel lines. You're going to find the point of the triangle that's not being used in the parallel lines, and that's where we're going to start from. So on this problem, here's the parallel lines. Way down here on the right, this is the only point of the triangle not being used. So you're going to go down one side and then go down the other side. So I have 20 over 8, which I have here. Then I have 4x plus 1 over x plus 4. Now the difficult part here is you have to distribute. So when you cross multiply, make sure that 8 goes on the outside and you have a set of parentheses and you put the 4x plus 1 inside the parentheses. And the same thing, you have 20 on the outside and x plus 4 on the inside. So now we're going to distribute. So when I distribute, I get 32x plus 8. And then 20 equals 20x plus 80. Let's start solving. I want to take the 20x to the other side with subtraction. And then I'm going to subtract the 8 over and then divide by 12. So I end up with the answer of 6. So if I went too fast, feel free to pause it and look at it and see if you can do the algebra yourself. So for number 8, I notice I have an angle that's being bisected right here. So I'm using this third rule, the triangle angle bisector theorem. Okay, so I start where the angle's being bisected, and you can go around the left and you go around the right. So I have 20 over 60. 16. Sorry about that, 20 over 16. Then I have 4 over x. Now, once you have your proportion made, you're just going to cross multiply. So 16 times 4 is 64. And then 20 times x is 20x. Divide by 20, and I get x is 3.2. Now, number 19, it has a very tricky part to it. So here's how I always explain this first. So if, let me draw a little better of a picture. Okay, so let's just say I have this entire side, and I know, let's just go with 18. And I know this little tiny piece is 5. How could I find that missing part that I have highlighted in yellow? Well, that's pretty simple. That's kind of like the segment addition postulate. A little segment plus a little segment equals a big segment. Or it's like an algebra problem. X plus 5 is 18. So how do you, if this yellow part's the x, how do you solve for it? So you just subtract 5. So really, isn't x just 18 minus 5? So I'm taking the whole amount and then I'm subtracting away this little amount. So let's try to apply that to our problem here. If I know this entire length is 18, which if you look here, they tell you that entire length is 18. But now here's the tricky part. Instead of saying it's 5, they say it's x. Now, on the first example, I subtracted. So it's really not going to be any different on our main problem over here. You're still subtracting. So this little bit that I don't know, this part in yellow, it's 18 minus x. It's the entire length minus x, the part I don't know. So that's the hard part. Now, once you understand that, you're going to find the angle bisector, which is right down here on the lower left, and that's where you're going to start, okay? And so now I'm going to go up and over and down and around. So I have 15 over 18 minus x, which I have here, and I go back to where I start, and then I have 10 over x. So now that you have your proportion, you're going to multiply and do your cross products, like cross multiplication. So go ahead and try to do that. Make sure you use parentheses here. It's 10 parentheses 18 minus x. And then you're going to have to add the negative 10x to the other side with using addition to make 25x. And then I'm going to divide by 25 to get 7.5. All right, we're doing a great job here. Let's try to finish up number 10. All right, so when I look at this, I see 3 parallel lines, and we had a rule about that. Let's go back and look. Isn't that going to be the second one, the corollary, which is like this part here? That really wasn't so bad. Okay, now it has the tricky part. Remember the tricky part from the previous problem? If I know this entire length is 35, but I know a little bit of it is x, how can I find this other little part? All right, so we're going to take the whole entire amount, the 35, and then I'm going to subtract away the x. And so this top part, guys, it's going to be 35 minus x. Think about it. If you have 35 minus x, and then you add x to it, doesn't that just equal 35, which they told you is the total? Because those x's cancel. So it's a hard idea to get your head around, but once you get it, it really does make sense. Now, once I have this number, once I have this 35 minus x, now you can write your fraction. So I'm going to start over here on the left and just say 20 over 8. And then go to the right side and say 35 minus x over 8. So I have my proportion now. We're going to cross multiply. Remember, parentheses are your friends. You're going to distribute. 8 times 35 is 280. 8 times negative x is a negative 8. Okay, so you have a negative 8. Let's take it to the other side. Let's add it. So when I add 8 to both sides, it becomes 28. And then I divide by 28, and I get 10. All right, so we're down to the very last one already. All right, so the map at the right shows a walking path at a local park. The garden pathway is parallel. So guys, this is information you need to put into your picture. Put the little parallel symbol in here. To the walkway between the monument and the pond. How long is the path from the pond to the playground? So pond to the playground. Okay, now before I can figure out how far that is, because that is really a second question, I first need to find the value of x. So when I look at this, I see the two parallel lines. Let's go back up. I'm using this first rule again, the side splitter theorem. So I'm looking for two parallel lines, which, yes, we have. Which point of the triangle is not being used with those parallel lines? And it's right here on the left. And then you can write your proportion. All right, so way over here, I have my proportion. 20 over 24, and then 2x plus 10 over x. Okay, hopefully we're getting really great at this cross multiplication stuff. Use parentheses to get 48x plus 240. Subtract 240 to get 12x, and then divide by 12. Now, I know a lot of people would stop here, but do you remember how we have to go back and finish the question? How long is the path from the pond to the playground? Okay, so if I know x, I can plug it back in. And so what I did is I said 2 times 20. Let me back up. That's not the highlighter. 2 times 20 is 40 plus 10 is 50. And the second part here is x, so that's another 20. So 50 and 20 is 70. From the playground to the pond is 70 yards. All right, so we are officially done with Chapter 7. Congrats. If you have any questions, please let me know.